marker pictures. We need one. Have a marker?
Yeah, but I just had, it's not here.
I'll be sitting for most of the time and then moving. At the end of that, I want to go and explain MapReduce. So this talk is about MapReduce. So it's not really about what people call Google MapReduce, Hadoop public data, any of those things. It's just about understanding the concept of MapReduce and how can you use it in your day-to-day tasks. Okay. So I got stuck into one problem which was not able to solve with the regular methods. Then I realized that MapReduce actually solves this problem much better. I'm going to share my experience with you. So what's MapReduce? It's a very nice abstraction that can solve a particular class of problems very elegantly. So we'll actually see what kind of problems it can solve. Okay. Let's look at an example. Let's say computing the frequency of words in a given text file. Okay, that's pretty simple program. Okay, any person who just know enough Python can use the right one. So you just take a list of words and then loop over them and then put them in a dictionary and then return the frequency. So the key part is frequency. You take the word from the dictionary, you add one, and then store them in the dictionary. This works fine, but what happens if the input that you have doesn't fit in your RAM? Okay, so this is a very simple problem. It's not a hard problem to solve. Okay, but the thing is now the problem comes when your input data size becomes very large. It doesn't fit in your memory. So the traditional approach of writing like this doesn't work anymore. Okay, now so you have a program and then suddenly you realize that the data size increased 10 folds and it doesn't fit in your RAM at all. Okay, and that might be a program that you run once in a month. You can't afford to buy 10x powerful machine just for that. So what can you do? So MapReduce actually helps a lot in this kind of cases. So let's try to understand what MapReduce is. Okay. So it's a simple programming model that takes care of how to deal with the large data. Okay. And all as a programmer you need to do is to specify what element each record. So when you look at large data, it's a set of records. A record could be anything. A record could be a line in the file, or it could be a JSON record, or it could be anything. Okay. So if you consider a case of word count, you can consider each line as a record. So to MapReduce, you just tell what to do with each record, and then how to combine the results. So if you tell these two things to MapReduce, it takes care of everything else. So how to do with large data, and how to store it, how to split it. It takes care of all of it, and then all you need to do is, for your problem, you specify these two things. Let's try to now look at word frequency using MapReduce. So what we are doing here, given a line, we need to tell what to do with that. So we are saying that for each word, count is 1. Okay. So I am taking a line, splitting that, and get the words. And then for each word, I'll need key value pairs. The key is here the word, and the value is 1. When you reduce, so now you have a lot of key and value. You have a list of key and values. So you want to combine them. So what you do is you find some of them. Okay. Let's say now let's just take an example here. Okay. Say you have A, B, C, say A, B, C, B, and C, and 3 lines. Okay. So pass to this, each line I'm treating as a record. So this is A1, E1, C1, and this line is B1, E1, C1, D1, C1. Now it's the job MapReduce to take all these things and then somehow pass it to this. Okay. So we'll see actually what MapReduce does. Okay. So behind the scenes, what happens is someone is actually, the MapReduce framework, what it does is it takes all these records, calls map function, calls ABC, and passes to the map function. So you get these 3 things from this record, you get these 2 from this record, and these 3 from this record. Okay. Now, next thing what it does is it collects the records of map and groups them very key. So what it does, it takes these things A, what are the values that it has in A? It's only 1. So it takes A and that has a value of only 1. Okay. Take B, what all it has? B1 and 2. Okay. So B will get C will get again 2. B will again get S 2. E will get is S from. Okay. Let's add one more D so that it's get. So D I actually have here. Now, so this step actually somehow groups all of them and then calls the reduce function. So let's see what reduce is doing. It takes the key and values. So key and values is A, and this value is 1. So it returns A1 and B 2, C 2, D 3, 1. Okay. So now, nowhere in our program we specify how to deal with large data. Right? So, dealing with large data is taken care by MapReduce. Okay. So that's the concept of MapReduce. Okay. So you look at Hadoop or any of these things that use MapReduce, what it does is you go and specify what you just specify these two things. Okay. What do we need to record? So how do you map it? Okay. And then you specify how to combine results with the reduce one. So once you do those things, then problem is solved. Okay. The next part of this is doing the map. So don't let the program that specify written something that's sequential in your program. You specify for each record, this is how you process each record and this is how you combine the results. Now each of the steps can be executed completely in parallel. But so we're not really going to talk about how to expert parallelism in that, but it is giving you hint that frameworks like Hadoop or Google MapReduce actually does these things in parallel. Okay. But the key part of MapReduce is the middle step. Okay. What it does is once you call map, it gets the result, and then it comes out somehow groups all the results and then calls reduce result. Okay. So now what I'm going to do is I had a problem which was not fitting in memory to solve. So I used simple MapReduce using just very simple really dumb way of implementing MapReduce. Okay, I'm going to show how I'm doing. Before I do that, I'm going to show you the code. Then I'll go back to. So this is the word frequency. Sorry. Do you know how to inverse this? Actually, this.
What do you want to do? What's the process?
Team. Actually, let me just open this in Gmail. I think I can. So basically, I have a small library called MapReduce here. Okay. So let me just say what open library before I get to it. So I work for a project called Open Library. That's a project of Internet Archive. That's a website to build a catalog of all books. So I have a lot of book records. So I have books with ISBNs, authors, etc. Each book is published by multiple people. So I wanted to group all the books, all the editions of the same book. So I have like 25 million book records. Each is a JSON record. So loading 25 million records, storing all of them in memory is not doesn't fit in the system that I'm working with. I have like 4 GB of RAM, but still it doesn't fit in memory. So what I did is use something like this. Okay. So I'm going to use the same little library that I wrote to compute the word frequency. That's okay. So what I do here is call read files. So what it does, it goes out file lengths and then reads all the lengths. Okay. So records framework accepts key and values as input. So I just delineate so that you get 1 line 1, 2 line 2, 3 line 3, etc. Now I'm doing that too. So I created a word frequency task and I define the block. We'll come to that. So I call task and process and bring the records and gives me this output. Okay. And I'm taking that out. Okay. Now see what I'm doing in the task error. So task takes key as value, right? So I'm giving in my input and in the records, the key is the line number, value is the line. So I'm using value to split, I get list of words. And then this is slightly different from what the example I showed before. Okay, so yielding one, I'm just yielding, I'm just saying. And then when you're reducing, basically counting how many of them are there instead of adding them. Okay, so now that gives me the concept there. Okay, so let me show a small demo of what it's doing. So so I just gave so it did a bunch of things, but let's not worry about what it's doing here. Let's see if it has got if it has got a bunch of counts. Okay, for all the files that are given. Okay, so now the crucial part now is MapReduce is fine. It's pretty simple. Okay, but the crucial part is now what the MapReduce is doing behind the scenes, right? So you see, the very crucial part is this. Okay, the driver, the MapReduce driver. How does the driver work? Okay, so take each record, calling out. That's pretty simple. Call reduce for each key. That's all simple. But how do you do this part? Okay, and see, I mean, here actually we're not really working at big input size. It's only working with one record at a time. Or here, one record and a bunch of values. This and this fits in only, but this doesn't fit in your RAM. So how do you deal with that? Yes, how to do that. So the thing is now, I have, if you look at the example before, doing one frequency, you might do actually a file of titles of size, and that should just work. Okay. So each line will be like 1K or something. So the map will work. It will reduce. The number of counts will probably be 1,000. So that's all it should work. But how do you calculate the values and then combine? Sorry?
Using a generator function.
No, see, you can't store in memory. It doesn't fit in memory at all. Okay. So the whole point of MapReduce is that you can solve problems which doesn't fit in your memory. Okay. Whether you do it, parallelize it or not.
You can do it multiple times for each key.
Sorry?
You can do it multiple times for each key.
Okay. But how do you? So the thing is, see, the key part is like group them by key. Okay. So that's very crucial part for MapReduce. Okay. So one way to do it is you create one file for each key and for a pending file.
Using an enumerate function.
No, so enumerate, that's just the create values. Okay. So the key part is group them by key. So how do you do that? The dumbest way to do it is for each key you create a file and then write that file. Right? Sorry?
Storing for each file for something like that. Again,
well, I mean, so that's why I say it's not the best way. It's very dumb. Okay, but still that will work. Okay, we probably create a million files, very slow, but still work. Okay, but yeah, as I said, it's not really nice. Okay, so what do you do? Now I can start writing all of them into a single file, and then sort it. How do you sort such a big file? I mean, that's again is it's very hard problem. Okay, sorting terabyte of thing. Okay, doesn't really work very well. Okay, so what I did is I'll show you this. So once you get all these keys, I split all the keys into 100 buckets. Okay, so write into one file, arrange to 100 different files. Okay, so how do you decide which file to go? I take the hash of the key and then by 100 and then it goes to one of those bits. Assuming that data is random, it will goes equally to all the fields. So this one goes into file 1. Okay, so whenever I get A, it always goes to file 1. And then I have like 100 of these files. So whenever I count each key, it goes into split across all these 100 files. Now I have 100 files. Yeah.
So you're trying to implement the shuffler here, right?
Yeah.
Map shuffler.
Yeah.
But isn't the shuffler a part of your MapReduce library?
That's it. I'm talking about how the MapReduce library is working. Okay. So this is not the end user is writing. Okay. So this is just the part of MapReduce framework. Okay. So the shuffler, what it's doing is it takes the key and then hashes it and then writes one of these files. So at the end of map operation, I have 100 of these files generated. That's again configurable. I set it 100 because 1/100th of the input size fits in my RAM and sort can work very efficiently on that. Okay. When if I take the whole of input, that's like that comes to more than 10 or 12 gigs. Okay, which doesn't fit in my memory at all. So but when I split it into 100 parts, so I build it into 100 different files. Each file size will be like 100 MB or so. And then what I do is I have a concept called disk. Okay, so you basically define which directory you want to use, and then tell the hash function. Okay, so what it does is when you write, it finds calls hash function and then divides the number of files and writes the file. It writes a key and value. Okay, I'm using that both key and value as strings because that's simple enough for my implementation. So you write the key and value, right? Okay, and then close it. And then it has a function read semi-socket. Okay. So what it does is it takes so there's one more thing I'm doing is to save space. I'm writing the files in zzip as zzip so that the size is less. So as I'm writing, I'm opening it as a I'm doing zzip.open that actually opens writes the file as compressed directly, and then when I want to read it, okay, no, I don't want to sort all the input. All I need is to group by key. I really don't want to sort all the input. So what I do is I sort each of these files, content and all of them, and then send it. So what I do is for different files, I just call zzip when cd and bib file. It's just OS.system when you reach file. Okay, so what it does is I'm using some OS.open, it opens that, and I read standout needs the key and value. So what I'm doing is I have 100 of these files. For each file, I'll sort it and then read the sorted output and then read it back. So this is doing the group part that I mentioned previously. Okay. Now, what do you get? You get all the same key come next to each other, right? Because you have sorted the input by key, sorted input. All the same keys will come next to each other. Now, reduce is simple. You go over that and then take all the keys and then pass it to reduce. That's all. Okay. So if you see when I'm running this program, you see, so it's actually I created a shard, 100 shards. So it goes to 100 of them and then sort. And then I give when I sort, you can specify how much memory it can use. Say it can use memory of 1 GB. So now this works very well. As long as your input size is 100x your physical memory. Okay, that's pretty good enough for most of my needs, and so that's how I did that. That's it. So any questions?
This one of the Unix.
Yeah. Unix. Oh no, it's nothing really stopping me from working on some other platform.
Okay. If we have to
Oh yeah, sorry. Yeah, the sort. Yeah, sorry. It works on Unix because I'm using Unix sort. Because I really see Unix sort is actually a very efficient program. Okay, I really don't want to implement sorting in Python again. Okay, and this is something which I wanted to do for a script that I want to run once in a month. I really don't want to spend so much of efforts to optimize to squeeze every bit of performance. I just want to make sure this runs reasonably well. Okay, you can finish in a day and doesn't like bring the machine down. That's all was the need.
this will not work across machines, right?
I'm not doing it. See, the thing is, even sort, I have like 8 cores machine. Okay, I'm not even parallelizing it. Okay, I mean, I can actually could have run sort parallelly. But the point is now.
No, it will not work because when you group your keys,
Yeah.
there's a kind of it's properly sequential. Looks like you're not doing it in parallel.
No, No, I'm doing it sequentially, but there's nothing stopping me from parallelizing. See, I didn't parallelize it because that was not my priority. The priority is to handle this big input size on my machine, on my tiny machine. Okay, but you see, the sort could be very easily parallelizable. I didn't do it because I didn't want to spend time on it.
So what I'm trying to say, you have these 100 buckets, right?
Yeah.
A set of two
Yeah.
machines.
Yeah.
We have, say, a set of keys. I don't immediately see how it works.
So this thing I'm not trying to run on multiple machines. It's not really designed to do that. Okay, it's designed to run on a single machine. Okay, but I'm saying still it can be parallelizable by making the sort. Any of these things work on multiple. Start multiple processes and start doing this. Okay, but the whole point of what I'm going to convey is not how to parallelize MapReduce. So the point is how do you use MapReduce to actually work on data which doesn't fit in your RAM. So that's what I'm trying to convey.
So your reducer,
Yeah.
are you running your reducer sequentially or are you trying to run them in parallel with threads?
I'm not. I'm running it sequentially. Okay.
Okay, because talking about running it on a single machine itself,
Yeah.
not even trying to distribute it. But so once you get these lines and columns and everything, you would want to output it somewhere, right? You would want to write it in an output.
Yeah.
So if you have reducers running in multiple threads,
Yeah.
and if you want all your reducers to write to the same file,
Yeah.
you again have a bottleneck there, right?
Yeah, so see, the thing is that
You don't have to write it.
that's true.
Sorry?
You have different files for each process, and then just handle them later, and sort them in parallel.
So you sort them in parallel, okay? And at the end, at the end you actually collect all the reduced outputs and then write a single file, okay? But see, I didn't do that because that was not my priority. Yeah.
So your process will be the text file. That's right.
Yeah. That's configurable. You can make it 1000 if you wanted to work on.
Why do you need Gzip?
Sorry?
Why do you need Gzip?
Gzip?
Yeah.
I felt the bottleneck is disk I/O most of the time in my case. Okay. So to reduce the disk I/O, so
Did you weigh the time difference between encrypting it and the disk I/O?
yeah. So it's trade off between CPU time and disk time. Okay. So I don't have the numbers right now, but
Even I don't know, so I'm actually
yes. So in my case, it turned out to be disk I/O is more expensive than CPU. So that's why I'm doing this.
And in this case, are you planning to make it parallelized or
No.
if you're not, then there is no need to make all of these files. You just run map on separately and just keep on reducing them one by one. Why write all those files?
No. So the key part of MapReduce is this. So if you go back to the slides, see, group them by key, right? This is important part. So when you for reducer, you need to pass all the items of the same key. So if you look at the work I'm doing using MapReduce, is I wanted to find all the words, combine all editions of the work. So edition is a book with an ISBN number. Okay, so if you look at Harry Potter, whatever the book title is, okay, and there are multiple people who publish. One published in US, one published in UK, one in India, and it's reprinted again and again. So it's like that work of Harry Potter, okay, that one volume has like 20 different editions. Now I have 25 million editions with records with me, and I want to group them by word. Okay. So what I want to do is I wanted to combine all of them by word, and then I wanted to create a Solr index out of it. Okay. Now to create that that output with each work and all of its editions, I need to now know that what's the work and what are all its editions are. So what I do is I go. I can show you the code later. But what I do is I go over all the editions. For each edition, I emit the work ID and the edition JSON record. So now, when you group them by key, so all the work edition, all the editions of the same work come together. Those are passed to the reduce function. So reduce function creates a new JSON record combining all of them. So that grouping is very important. So you can't just take do map and then pass it to reduce. Any more questions? You want to go over the program scale, or you want to see the real program that actually used to run this MapReduce? So I'll pass example code for this is here, and I'll pass on the slides and things to Trey so that you can put it on the MapReduce website.
So this MapReduce is actually beneficial only because in your input set, there are keys which are similar but occurring at various places in the input set.
Yes.
So if all of them were to be unique, then what would they do?
No, if all of them are unique, then you can just do sequential pass and then output. So that's so see, then input size doesn't matter at all. Okay, for example, you want to find number of words in each line. Okay, then you don't need MapReduce at all. Okay, just go over sequentially and then you emit out the words. Okay. So this is, that's why I said MapReduce is something which solves a particular class of problems really elegantly. I mean, if the problem doesn't fit into that, then so most of the common use case is called the invert index problem. So you have a document that has a list of words. We want to find out all the documents containing that word. So that's what search engines does, right? So you take a web page, and web page has this 10 different words. Now, when someone searches for that word, we want to find out what are the documents which has this word. So that's the inverted index of that. So those kind of things work very well with MapReduce. So if you look at the problem that I solved, you have list of editions, and each edition has a word, belongs to a word. I want to do the reverse of that. So these kind of things works very well. Done. Should I take this off? Yeah.